G'day guys, I've been given this question on inverse functions and implicit differentiation, where they provided us with the function 2 tan x, which is defined over the domain negative pi on 2 to pi on 2, and we've been asked to find the defining rule for g of x, where g of x is the inverse of f of x. So what I usually like to do to start with these ones, guys, is just write down my function. F is y equals 2 tan of x. So what I'm looking for is my inverse function, f negative 1, is going to be x is equal to 2 tan of y. Now what I can do is, because I need to write it in the form y equals g of x, I've got to make y in terms of x in this function. So I can start with going, well, x over 2 is equal to the tan of y. And then I can take the inverse tan of both sides, and I'm left with y equals tan to the negative 1 of x over 2. Or g of x is equal to tan to the negative 1 of x over 2. Okay, the second part of this question is asking us to use implicit differentiation to show that this inverse function can be written in the form a over x squared plus b. So first of all, let's rewrite this inverse function here, where we've got x is equal to 2 tan of y. Now using implicit differentiation, we're going to differentiate both sides of the equality. So I'm going to go, well, dx of just x on the left-hand side is equal to dx of 2 tan of y. Great. So first of all, d dx of x is just 1 is equal to, we've got the tan of y, so we're going to differentiate this with respect to x. So this is going to be, the differential of tan is 1 over cos squared, or sec squared. So let's just call it 1 over cos squared. So this one here is going to be 2 over cos squared y multiplied by, using the chain rule, the derivative of y with respect to x. So from here, guys, we're going to rearrange this so we can have dy dx is equal to something, and what you'll find is we're going to just multiply the 1 by cos squared of y and divide by 2, which will leave us with dy dx is equal to cos squared y over 2. Now this can be rewritten, guys, as just the cosine of y all squared over 2. And from here, we're going to rearrange this formula. So we have the tan of y is equal to x over 2. So from this, we can use a right angled triangle to relate the tan of y to the cosine of y. So here's one I prepared earlier. So we've said that the tan of y is equal to x over 2. So if we have an angle here, y, the tan is the opposite side over the adjacent side. So this would have to be x over 2. Now, if I'm looking for the cosine of y, I need the adjacent over the hypotenuse. Now, using Pythagoras, we can determine what the hypotenuse of this triangle is going to be. It's going to be equal to the square root of x squared plus 2 squared, or 4. And we can then say that the cosine of y is going to be equal to the adjacent side, 2, over the square root of x squared plus 4. Cool. So what we can do from that, guys, is we can just substitute this, and we're going to get dy dx is equal to, now rather than putting cos y, I'm going to put 2 over x square root of x squared plus 4, and that's all squared, all divided by 2. Now when I multiply into that bracket, I'm going to get 4 over x squared plus 4, and that's divided by 2, but I can multiply that instead by 1 over 2. Now we can simplify, and then I'm left with dy dx, or which is equal to g dash of x of 2 over x squared plus 4. Well, that's the end of my video, guys. If you made it this far, thank you for staying with me. If the video helped, please give it a like. Consider subscribing to my channel. I put out new videos like as often as I possibly can. And if you have any ideas for any videos, or if you've got any questions that you would like me to try and answer in the form of a video, please leave it in the comments section below, and I'll try and get to it as quickly as I can. But until next time, guys, just keep on practicing. Keep banging your head against the wall. These questions are hard, but eventually the wall will fall down. The moment of clarity, I promise, is worth the trials and tribulations. But again, until next time, guys, just keep enjoying your maths.